Resistance welding. Resistance welding is the most commonly used method for joining steel sheets. No filler metal is needed and the heat required for the weld pool is created by means of resistance when a high welding current is directed through the welded workpieces. An electroconductive contact surface is created between the workpieces by pressing them together. Contact is made using the shape of either the welded surfaces of the workpieces or the shape of the electrodes. Water-cooled electrodes made of alloyed copper are used in resistance welding. Electrodes convey a pressing force to the joint and direct the welding current to the joint in the appropriate manner. After welding, the electrodes rapidly cool down the welded joint. Work stages in resistance welding are very fast. The surfaces to be welded do not usually need to be cleaned before welding. In addition, to which the weld does not usually require grinding or post-heating. We will show you the resistance welding animation.
Resistance welding is a process where metal parts are squeezed between two weld tips. Current flows between the weld tips and encounters resistance at the weld tip interface and at the part interface. Resistance to the current at the part interface creates enough heat to melt the metal and cause a weld nugget to form. When the weld gun closes, the weld tips contact the metal and squeeze them together. The metal is squeezed for a short time to make sure that the weld gun is fully closed and that the full weld tip force is achieved. This is referred to as squeeze time. A squeeze time of about 12 cycles is used for small weld guns, and 25 to 30 cycles are used for larger weld guns. When the squeeze time is complete, electric current begins to flow through the metal from one weld tip to the other. The duration of the current flow is referred to as weld time. The current generates a lot of heat when it encounters the resistance at the part interface, and a lesser amount of heat at the weld tip interface. The heat at the weld tip interface is conducted away by the water-cooled weld tips, while the part interface continues to get hotter and hotter. About halfway through the weld time, the metal at the part interface begins to melt, then a weld nugget is formed. When the weld time is complete, the current stops flowing. Then a hold time of approximately 4 to 5 cycles is used to give the weld tips enough time to absorb heat from the outer perimeter of the weld nugget and cause it to harden before the weld tips open. A weld nugget should be as wide as the weld tip that contacts the thin metal and penetrate to between 20% and 80% of the metal thickness. This is referred to as a setup nugget. To produce setup quality weld nuggets, you need to understand how resistance welding is affected by weld tip alignment, weld tip force, squeeze time, weld tip size, weld current, weld time, weld tip cooling, and hold time.
Now, I will discuss the 3 resistance welding methods. The first method is the resistance spot welding. The second method is the projection welding. And the third method is the seam welding. Resistance spot welding. It is the most commonly used method where workpieces are joined by means of a lap joint. The maximum thickness of workpieces when producing lap joints by means of resistance welding is approximately 6 mm for uncoated steels and 4 mm for coated steels. Lap joints can also be made using projection welding and seam welding.
A resistance spot welder is designed to deliver a low voltage, high current electrical pulse. The weld electrodes are made of copper because copper has a low resistance to current flow, which allows it to conduct electricity with ease. Steel is a very poor conductor of electricity, and it will resist the weld current as it flows from the spot welder. The friction created by the current forcing its way through the metal heats the weld area to over 2,000 degrees Fahrenheit. The squeeze pressure from the weld electrodes now compresses the molten area and fuses the two metal surfaces into one solid nugget. By maintaining the squeeze pressure for a short time after the weld current is shut off, which is known as hold time, the molecules in the welded material remain compressed as the weld cools. This additional pressure results in a much stronger weld.
The next method is the projection welding. Projection welding is a variation of spot welding. Projections are designed in one part. These act as current concentrators for the welding process. When the two parts are mated together, these projections are the high points that first make contact. As the power is cycled, the projections simultaneously carry the current and are welded. This process is also known as resistance projection welding or RPW. Due to the efficiency of power transfer, thicker materials can be successfully welded. Materials as thick as 3 mm can be successfully welded. For thin stock, the traditional spot welding is a preferred method. Low carbon steels, low alloy steels, stainless steels, as well as aluminum can be welded using this process. The last method is the seam welding. Resistance seam welding is a process that produces a weld at the faying surfaces of two similar metals. The seam may be a butt joint or an overlap joint and is usually an automated process. It differs from butt welding in that butt welding typically welds the entire joint at once and seam welding forms the weld progressively starting at one end. Like spot welding, seam welding relies on two electrodes, usually made from copper, to apply pressure and current. The electrodes are disc-shaped and rotate as the material passes between them. This allows the electrodes to stay in constant contact with the material to make long continuous welds. The electrodes may also move or assist the movement of the material.